Hello. Please tell me if my voice is clear. Hello, hello, hello. Hello, hello, hello. It is clear. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So in the last lecture, we have completed the Huygens principle. We have studied about wavelets. Wavelet was so equivalent to equipotential surfaces. We have seen how both these things are similar. So if you are able to understand equipotential surface, easily you can understand wavefront concept also. And wavefront have explained everything. Reflection, and all these applications can be explained. I've told you about the brief history about the debate of also about light. Light is a particle nature or a wave nature. Now you tell me, what is the light? Light is a wave nature or particle nature? It is actually dual nature. That was I've told you that it was given by by whom? De Broglie. De Broglie proved that we will be taking it as a dual nature. Okay. So as of now, in this chapter, we are studying about wave optics. In the last chapter, what we have studied, geometrical optics. So, sir, what is the difference between both are lights? So why we are studying them differently? Now let's see, understand. The rectilinear propagation, I have talked a little bit about this rectilinear propagation in the last lecture also. Okay. In the last lecture, I have told you what is rectilinear propagation. That means light is always traveling the straight path. That part of optics is studied in geometrical optics. But actual wave nature, about wavefronts and all these things, actually I have proved that in the last lecture. And here also you can understand very properly. Okay. See, what is happening? Here is a light source I have attached. Here is a light source I have attached. And here I made a hole. Here I made a hole. Small hole. What will happen if light is passing straight away? It will go and it will reach here, and then I made the second hole at this point. Correct? That means light will never come to the third hole. Light will never come to the third hole. But is it really? Is it? It will be practically happening? Actually, no. Actually, not. Why? Because light is a wave nature and it will also bend its path, and when it will bend its path, what is diffraction, all these things will be studying. There is some required conditions when light bends its path. So when it is the case, what will be happening? Light is actually will be reaching to the third one also. See here what is explained. When light passes through the hole having dimension greater than the wavelength of light, the light ray travels in the straight line without changing. When wavelength of light is a lot greater than the it's greater than the actually whole dimension is greater than the wavelength. What is the condition for passing straight away? It is, what should be the condition? That dimension or size of hole should be greater than the wavelength of the light. If this is the case, then light will be passing simply in a straight path. Light will be passing in a straight path. But if this dimension of this hole, if the size of the hole is nearly similar or equivalent to the wavelength of light, then I can say it will bend its path, then it will be performing diffraction. That is a separate chapter that we are going to study. Not a separate chapter, separate topic in wave optics itself. Okay, we will be studying it as a separate topic in wave optics. So then we will understand that how this diffraction is happening, how bending is happening, and rest of the cases. So these portions where bending will be seen, it is what we are going to understand in the wave optics. And the rectilinear propagation, when the dimension or the size of these holes were a lot greater than the wavelength of light, then it passes straight away. Okay, fine. So now let's understand, and the first and foremost thing, first phenomena that you have to understand is interference. I will say that from a very long time we are already understanding interference. What is in SHM also we have studied about interference. Just the creation of wave will be called as interference. What is a wave? Wave is a combination of a lot of number of SHMs. Okay, there will be some crest, there will be some trough. Okay, amplitudes, time period, all these things we are studying from SHM. Let's quickly summarize that, and let's understand from an example. Okay, see, let's suppose a still water, a water can is there, a light can is there, and what is floating on a water. Okay, and let's suppose you have dropped a particle into the water. What will happen? A wave will generate like this, and this will be shown by this movement of this or can also. Sometime it will be at upper side and sometime it will be at downer side, sometime up, sometime down. This way wave will be generated, and that is what actually called as interference. Now see what will happen. Let's suppose you are throwing a very heavy particle. Then what will happen if a stone of slightly heavier than the previous one is dropped on the left side of the can, let the it is raised by 8 centimeters due to the wave generated. Last case it was came up by 4 centimeters due to some light stone. Now you have thrown some heavier stone, that means more amplitude will be coming. This 8 centimeter or 4 centimeter is reflecting what? It is reflecting the amplitude actually, correct? Now let's suppose consecutively you have thrown both the things. You have thrown the first particle due to which 4 centimeter amplitude was raised, and now again you have thrown the second particle also, or second stone also, due to that 8 centimeter was. Now combine, if you have thrown, how much amplitude will be raised? That will be 12 centimeter. When you are throwing this both combined, it will be raising by 12 centimeter, and that is what interference is. Now in interference we study about a very important concept, that is superposition. What is superposition? Combination of two waves, two traveling waves is called as superposition. And how we write the equations? Now I hope that it is very much similar to you, just we add up the amplitudes in vectorial form. Okay, for example, let's suppose here you have three different waves. One wave is represented by blue color, second wave by green, and the third wave is represented by yellow color. These are the three waves that you are having, y1, y2, y3, let's suppose, and all these three are getting superimposed. What is superimposed? Superimposed means they are combining at every places. So what will be the new equation that will be generated? By combination of these three waves, you will get a new wave, and that is what superimposition is. See the definition: when two or more waves crosses at a point, the displacement at that point equal to the vector sum of the displacements of an individual wave. Exactly what I have told you, because what is the general equation of a wave? From a very long time you are studying this equation: y is equals to a sine of omega t plus of kx plus of phi. This is the general equation that you can say. Okay, so the net sum of the displacement that is made by them will be called as, so let's suppose it is having a displacement of y1, it is having a displacement of y2, it is having displacement, or it is the net wave that is drawn. Third one is the net. So how you will be writing the net? You will be writing the resultant wave, you will be writing as y1 plus y2 in terms of vector form. In terms of vector. And I have told you in SHM only how to represent the equations in the vector form. How you represent that? You remember phi is equal to 45, that means from the reference line you will be taking a 45-degree angle, correct? All these things you have to do. So let's understand how we can do. Before that, understand one more thing about their superposition will have been kind of two type. Okay, so we will come to constructive interference and destructive interference, that is a later part. Let's understand the simple case here. Two wave pulses are there and both are coming in the same direction. Both are coming in the same opposite direction, that means they are coming towards each other. And let's suppose it have a amplitude of 1 and it have an amplitude of 0.75. Now what will be happening? They are getting superimposed at some point, and the amplitude of the resultant wave, how will give? Simply add up them, because both are in the same phase, they are traveling towards each other in the same phase. So simply addition will be happening with the amplitude, correct? Now the second case, let's suppose a wave is coming, the amplitude is 0.50 and the second wave is traveling by amplitude is minus of 0.50. But this time what is the difference? The phases are different. The phases are different. Now when they are going to superimpose at a point, what will be the net amplitude that will be writing? It will be plus 5 minus 0.5, because it is in different phase. The answer will be 0. So what is there is general formula for this? Yes, we do have the general formula, and all of you know about that general formula. I will say from the first chapter that you have studied about physics, that was vectors, from that time you know about this formula, if I will tell you. So there is nothing new, so you should be answering what is the general formula for the resultant of amplitude. If anyone knows, you can comment down in the comment section. See, there is a small concept of coherent source, because all the derivations that we are going to do in this chapter is for coherent sources. Coherent sources means what? If two light sources are there, phase difference with time shouldn't be changing. That means phase difference should always be constant between these two. Phase difference should be constant, frequency should be constant, all these things should be constant. For a diagram purpose, if I will draw, there is an oscillator and it is generating a coherent source. Why I am saying coherent source? Because you can see all these three are looking like same, correct? What I can say, frequency is same, time period will be same. If frequency is same, time period will be same, and the phases, let's suppose if here phase is pi by 2, here also phase is pi by 2, if phase is 0, all these cases, all three cases, it is always, and with time also it is never changing. With time also it is never changing, it is completely uniform. these kind of things, what are the condition for coherent source? Same frequency, same wavelength, and constant phase difference. Okay, phase difference shouldn't be changed. That is a mandatory point. And that's why when I will be discussing YDAC, I will be taking two slits. Okay, why that will be, I will tell you a story behind that also, why we have taken that. Now, what is incoherent sources? Now it was very simply, beautifully explained by the diagram. Here, see, this is the first wave, second wave, and the third wave. Can you see any difference? Correct. I can see that there are differences about phase also. They are in different phases. There is a change in frequency also. Frequency of wave is also changing here. It is have a high frequency. It is having low frequency. Okay. So these many things you can define. Now let's come to interference. Okay. Let's suppose a wave is source is 1 and this is source 2, and they are traveling, and here they are going to superimpose at point P, and I want to see what will be the resultant wave that will be generated by these two waves. And how I will be writing that? I will be writing that it is equals to y1 plus y2. That is what we are going to do. So the net equation, final equation will be coming. Let's understand here. See what is happening. I will tell you from complete scratch. Let's suppose this was source 1, this was source 2. Light is traveling. This is having a y1 is equals to some a1 sine of omega t plus of kx plus of pi, and this is some y2 is equals to a2 sine of omega t plus of kx. Let's suppose these are the two equations here, plus of pi. The phase difference. Now understand the terms. What are the terms I am telling you? See, at point P there is a superimposition. At point P there is a superimposition. What will say? The resultant wave will be equals to y1 plus y2. And how I will be writing? I will be writing resultant amplitude sine of omega t plus of kx plus of phi. Resultant amplitude into sine of omega t plus of kx plus of phi. Correct? Sorry, no, I will not write phi. I should write it as alpha. What are these things? I will tell you. Okay. So those students who have not studied about SHM properly, they will try to understand here what I am trying to say. What are these terms? In a general equation, you would be knowing this complete term is called as what? Phase. This complete term is called as what? Phase. This phi is called as what? This is called as initial phase. This is called as what? Initial phase. This is called as what? Amplitude. This is called as what? Amplitude. Now this will be, you have to represent both these equations on phasor method. How you will be representing? I've always told you, whenever, let's suppose here it is written a1 sine omega t plus, or if it is nothing, I can say 0. So represent it on the x-axis. Always take the reference at x-axis. Represent wave 1. What is the amplitude? A1. What is the amplitude? A1. Now let's focus on the second wave. Second wave, what is the equation? A2 sine of omega t plus of pi. That means what? How much phase difference is coming there? Phase difference, if I will ask you, phase difference is coming 5. Phase difference between these two equations is 5. What do you mean by phase difference? That means the angle between these two vectors is how much? 5. So I will draw A2 at some angle, and the angle between them is 5. Now, if someone will be asking me, tell me what will be A resultant? Batao. How will be writing A resultant? Two vectors are there, angle between them, cannot you calculate what is A resultant? Simple. I am not going to calculate. A resultant will be directly, you can writing as, this will be the direction of resultant of two vectors. It will be represented as root under A1 square plus A2 square plus 2A1 A2 cos of phi. This is the formula for resultant amplitude. What is the formula of resultant? Remember, all these things, complete wave optics is connected. So every single thing that you are understanding, whatever I am telling you, you have to remember it, memorize it anyhow possible. Because I am going to continuously use these terms again and again. So that's why from now, the interference portion till the end of this chapter, everything will be connected and you have to remember every single thing. Okay, very good. Now, what is this alpha? Sir, what is this alpha in the general equation that you have written? Alpha is better this angle of the resultant amplitude with the A1 vector. That angle is called as what? Alpha. or from the reference line, you can say. In general, if I will tell you, from the reference line, whatever the angle that you have taken, that is called as alpha. So here reference line I have taken as x-axis, so that will be called as alpha. So if I have to define alpha, sir, how I can define? I can define, sir, it as tan of alpha. कैसे लिखोगे tan of alpha? How will be writing tan of alpha? Simply see what you can say about this one. If you know about triangle law, अगर वैसे तो directly लिख सकते हो, but if you have to draw triangle law, what you can say, this will be what? A1. If you are making a triangle law, this will be what? A2. And what is this angle? This angle is nothing but phi. So drop a perpendicular. What you will be saying about it? This is called as what? Resultant. This is called as what? Resultant. And what you can, already I have told you about the resultant formula, a root under a1 square plus a2 square plus 2a1 a2 cos of phi, and this angle is alpha. कैसे लिखोगे alpha? What is this side? This is a2 cos of phi, this is a2 sin of phi. This component will be how much? A2 sin of phi, and this component will be till here, it is what? A2 cos of phi. So if you have to write alpha, now you can better way understand it. What is tan of alpha? Perpendicular, that is a2 sin of phi divided by the base. What is the total base? It is a1 plus a2 cos of phi, a1 plus a2 cos of phi. This is the formula that you will be writing about tan of alpha. So both these things are important. Most of the time the question will be from resultant amplitude. Just calculate the resultant amplitude, your work will be done. Otherwise, if someone is asking you about the angle, this alpha, if you have to write the general equation, like I will give you an example also, there maybe you have to use tan of alpha, and I am telling you it is very obvious, very easily you can calculate. I will never say that remember the formula of tan of alpha. It is very obvious thing, you can understand according to the question. I will tell you also how you will be calculating, don't worry for that. So this was the complete derivation that you will be having. Okay, here it is represented in pictorial form. It was wave y1, a1 sine of omega t minus of kx. Here it is wave 2, a2 sine of minus omega t plus of phi. What is the phase difference? Phase difference, simply divide, this is phase 1, this is phase 2. Difference when you will be taking, the angle between them will be coming as phi. Angle between them is coming as phi, and then if you have to plot the resultant wave equation, what you will be writing? y1 plus y2. What will be the equation? A resultant लिखने बता दिया है, into sine of omega t plus of kx plus of alpha. This is what you will be writing about the resultant equation. Correct? Here you can see all the things are here. A net, how you will be writing alpha, how you will be writing alpha formula is derived. Already all these things are provided in your notes, so don't worry for that. See, there is a question. Okay, there is a question. Try to solve this question, that's so that you can understand how to apply this thing also. Let's see what is the question. See, question is, if it is not properly visible, I will tell you here. This is what you have to calculate, y net, and the equations are 4 sine of omega t plus of 30 plus 3 sine of omega t plus of 120 plus 120. Okay, fine. I have to solve this. So what is the resultant equation? Y net in general, what we write? We write it as y, or a resultant, amplitude resultant, into sine of omega t. From where we are calculating, from 4 we are calculating omega t plus of 30 plus of alpha. This is what we are going to do. Let's represent this in phasor method. Okay, let's represent. So firstly, I am going to take this as a reference. This is 30 degree, this is 120 degree. I am going to take this line as a reference line. So I will be drawing, and I will assume that this is what my 30 degree line. And what is the amplitude? 4. This is what is the amplitude? 4. I have drawn, and I will say that this is a reference line at 30 degree. Now, how I will be representing the second line? What is how I can represent the second line? This is what is the difference, phase difference between them. This is 30, this is 120. But the phase difference क्या होगा? Phase difference, just differentiate the phases. Can you say you will be having 90 degree? Correct? That means I will represent this 3. Amplitude is how much? A2 is how much? 3. This was A1, amplitude 1. The magnitude is represented. This is 3. And what will be the angle between them? 90. Very simple thing. Correct? Now, this is what we can do. Now, what I have to do? I have to calculate the resultant amplitude. Resultant amplitude. कैसे calculate करोगे? What is the formula of A resultant? It will be root under A1 square. And can you say it is perpendicular? That means cos of 90 is going to be 0. तो लिखने का कोई point नहीं है. So just put the values A1. A1 is how much? 4 square A2 is how much? 3 square. Net it is going to be root under 25. That means answer is going to come as equals to 5. Answer is going to come equals to 5. So first thing you got that resultant amplitude is how much? 5. Second thing, in this equation you have to calculate alpha. अब बताओ alpha कैसे calculate करोगे? Do you need to apply that much of long formula? Is it really? Do you need? No. That's why I've told you that alpha you can calculate always by some common sense. You should have that much of common sense if you're preparing for a competitive exam. कैसे calculate करोगे alpha बताओ? Alpha is this angle from the reference. I have told you from wherever you are taking the reference, that angle is called as alpha. So if I have to write tan of alpha here, what I will do? Perpendicular divided by base. If this is alpha, this angle, what is the perpendicular that I have in this right angle triangle? 3. What is the base I have? 4. What is tan of alpha is equal to 3 by 4? What I can say about alpha? Can I say alpha is nothing but equals to 37 degree? Alpha is equals to 37 degree. Both the values you got. Now write it again, put it in the net value. Y net is equal to resultant, that is 5 sine of omega t. 30 plus 37, that is 67 degree. 30 plus 37, that is equals to 67 degree. Hi King Pro. Is it clear? This way you will be calculating. I have told you how to apply this, and in the question series a lot of questions of interference we are going to understand. Don't worry for that. Okay. As of now, just understand this with the complete basic. Here the solution is also provided. Notes will be available for you. Correct. Now understand, there are now two kind of interference. Already you have studied in string and sound wave, but still I am going to explain you from the complete basics. Maybe it is in 11th part or PU1 part, so maybe you will have forget. So understand what always interference you have understood. Now there are two kind of interference. One is constructive interference, second one is destructive interference. From the name itself it is very clear. You remember that in last case what was happening? One time amplitude was getting add up and one time amplitude was getting subtracted. So where the amplitude will be maximum after superimposition, two conditions can be happening. Either amplitude will become maximum, either amplitude will become minimum. So the case when the amplitude is maximum, that kind of interference is called as what? Constructive interference. And the case in which amplitude, resultant amplitude will be negative, that kind of interference is called as what? Destructive interference. So let's firstly create the condition for constructive interference, and even we'll be remembering that because that will be a very important result for YDAC, Young's double slit experiment. There also we are going to use it. Okay, very nice. So what is constructive interference? What I have told you, just simply remember one single thing that will be helping you. Here you can write constructive interference. What is the resultant amplitude? Formula batao. Root under a1 square plus a2 square plus 2a1 a2 cos of pi. This is what your formula is. Now if you have to draw constructive interference means what? This resultant amplitude that you are having, it should be maximum. That means basically you have to maximize this equation. But how you can maximize this equation? How you can maximize? What are the things that you can control here? Can you say you cannot change the amplitudes? Not at all. But this angle cos of phi you can decide. Okay, at what angle I am going to keep it so that I can have the maximum resultant amplitude. So tell me, what is the value, maximum value of cos phi? Batao. What is the maximum value of cos phi? I can say simply, sir, maximum value of cos phi is equals to, maximum value of cos phi is equals to 1. Correct? Maximum value of cos phi is equals to 1. And at what angles of phi it is coming equals to 1? Batao. At 0 degree, at 2 pi, 4 pi, 6 pi. So can you say it is coming at the even multiples of pi? So what I can say in general, phi should be, if phi is equals to 2n pi, if phi is equals to 2n pi, then I can say cos phi is equals to 1, where n is equals to 0, 1, 2, 3 and so on. Put 0, it will get 0. Put 1, you will get 2 pi. Put 2, you will get 4 pi. So all these conditions of phi is going to give you how much? It is going to create the condition for constructive interference. I hope this will be clear. And let's, on the other side, let's calculate the destructive interference as well. Destructive interference as well. Destructive interference. How you'll be calculating? If constructive interference is maximum amplitude, what I can say about destructive interference? Destructive interference, that means the resultant amplitude should be minimum amplitude. Destructive interference means amplitude should be minimum amplitude. Now, how I can generate the condition? Again, I will say I can control this cos of phi. So what is the minimum value of cos of phi? If I am making this value minimum, I can say I have created the minimum amplitude condition. So minimum value of cos phi is equals to -1. Minimum value of cos phi is equals to -1. Now tell me you that at what angles cos phi is equals to or cos theta is equals to -1. I will say, sir, pi, 3 pi, 5 pi. This kind of angles will give you -1. That is the minimum value. Okay. So in general, what I can say, I am having the odd multiple of phi. So how I can write odd multiples of phi? I can write in general phi should be equals to 2n plus 1 pi, where this is a necessary condition for destructive interference, and where I will say n is equals to 0, 1, 2, 3 and so on. Put kar lo 0, you will get phi is equals to pi. Put 1, you will be putting 3 pi. To put 2, 5 pi and so on. When you will be putting all these values, you will be having the condition of destructive interference. You will have the condition for destructive interference. These two are very, very important, I will say, because these are going to create the lot of derivations. Okay. Should we discuss about path difference also? Should we discuss what will be the path difference? See, what will be the difference path difference that you will be having? Should we start? Or let's as of now understand here, and let's see path difference. So this was the condition that I have told you here. Okay, will be discussing about path difference as well. See, so maximum amplitude will be what? As of now, in constructive, if it is a constructive interference, what will be the value of cos phi? 1. So what will be your resultant amplitude? Write the resultant amplitude. Resultant amplitude will be equals to root under a1 square plus a2 square plus of 2a1 a2 cos of phi. Maximum value of cos phi batao 1. That means what will be remaining part? Root under a1 square plus a2 square plus 2a1 a2. Can I write it also as a1 plus a2 whole square? That means I can write, and there is an under root, that means I can say a maximum amplitude is equals to a1 plus a2. साथ में ये भी बता दो what will be the destructive interference. So in destructive interference, what is the only change here? What you will be getting? That cos of phi is equals to minus of 1. Minus of 1 means what will be happening? a1 square plus a2 square minus of 2a1 a2. That means net I can say a1 minus a2 whole square. That means minimum amplitude, I will say, that is it is equals to a1 minus a2. That's it. This is what you will be saying. Is it clear? Is it clear? Now let's discuss about phase difference. What is phase difference? How you can calculate that phase difference? Okay. Let's suppose you are having two equations. There is not sufficient space to explain. See, here only, let's understand. Let's suppose you are having some general equation. I am saying a1 sine of omega t, coherent sources, so omega will be same, plus kx1 plus of phi 1, and some general equation y2 a2 sine of omega t plus of kx2 plus of phi 2. Let's suppose these are the two general equations that are coming. This is source 1 from where this y1 equation is coming, source 2, and again at point P they are going to superimpose. Let's suppose it have traveled a distance x1, it have traveled distance x2. If I will ask you, beta, tell me what is the phase difference? How you will be writing phase difference? What is phase? Phase is this complete term. Phase is this complete term. Now you have to take a difference, phase difference. How you will be writing? Omega t in first one, what you will be writing? Kx1 plus of phi 1, correct? Simple. In second one, what you will be writing? Omega t plus of kx2 plus of phi 2. Correct? Now you have to take basically the difference. Can I say omega t will be simply get cancelled out. What will be left here? Phase difference delta phi will be represented as kx1 minus of kx2, and here plus of phi 1 minus phi 2. Now for our in our syllabus, most of the time initial phases will be same. That's why they are going to be cancelled out, and it will going to give you 0. What is the remaining here? So the remaining portion that is here, you represent as delta phi, that is equals to k into delta x, k into delta x. Actually it will be x1 minus x2, and x1 minus x2, it will be what? Delta x. So this is called as what? Path difference. This is called as what? Path difference. Now what is path difference? Very simple. Let's suppose you are Ram. Okay, you are traveling 10 meter and your friend Sham is traveling 15 meter. Tell me simply, what is the path difference? 5 meter. How you have calculated? Just take a difference between the distance. It is not a rocket science. It is very simple, and keep it simple. Okay, so this is what path difference. If I'm asking you, better tell me what is phase difference, you will be saying, sir, it is k into delta x. And what is the value of k? बहुत पहले से पढ़ते आ रहा हो. K is a wave number 2 pi by lambda. K is equals to 2 pi by lambda. Now come to the case of, again, constructive and destructive interference. Why I'm saying that? See, let's understand here only all the things. Don't worry, all these notes will be available for you. Okay, I'm explaining here. Okay, because all the notes are available, so there is not that much of space. I'm explaining here. Understand. Again, we are understanding constructive interference and destructive interference, both at the same time. Okay, now tell what is constructive interference. Firstly, amplitude should be maximum. How amplitude will become maximum? When cos phi will be maximum. What is the maximum value of cos phi? Cos phi is equal to 1. At what angles phi is equals to 1? At what angles phi is equal to 1? At all the even multiples of pi. That means what is the condition that we have generated? Phi should be equals to 2 and pi. Yes or no? Yes or no? तुमने ये calculate किया है, correct? Now, what is your path difference? What is your phase difference? This phi is what? Phase difference that you have written. Just now you have written that it is equals to 2 pi by lambda into delta x is equals to 2 and pi. Can I write this? Correct. So if I will ask you, tell me what is path difference for constructive interference, what you'll be saying? This 2 pi will get cancelled, and path difference should be equals to n lambda. Condition for constructive interference. Very, very important one. Very, very important one. If path difference is given as n lambda, where n is obviously, what is n? N is nothing but n is equals to 0, 1, 2, 3. These kind of things are n. So whenever I will ask you, let's suppose where it will be applicable, just wait for a moment. I will be explaining all these things when you will be seeing the fringes, fringe pattern, bright fringe, dark fringe, how you will be judging that by this path difference. All these things that is going to be judged by using this path difference only. See, what you can say, let's suppose I am giving you 3 lambda. I will give you 3 lambda. So I've given you 3 lambda as path difference. Now you tell me, is it constructive interference or destructive interference? You will say, sir, it is constructive interference. So let's see what will be happening for destructive interference. What should be the value? Exactly. Now, destructive interference, amplitude is minimum. How it will be minimum? When cos phi is equals to -1. What is at what angle cos phi is equals to -1? Let's write that condition. Cos phi is equals to -1 at phi is equals to odd multiples of pi, that is 2n plus 1 pi. Correct? And phi, how much we have just created? 2 pi by lambda into delta x is equals to 2n plus 1 pi. From here I can relate the path difference. Pi cancel. Path difference can be written as 2n plus 1 lambda by 2. That means what is the value of n? nr. So path difference, if it is given, put 0, what will be getting? Lambda by 2. Put 1, how much you will be getting? 3 lambda by 2. Put 2, how much you will be getting? 5 lambda by 2, 7 lambda by 2. If you are getting these lambda by 2, lambda by 2, lambda by 2 terms, what you will be saying? Sir, it is destructive interference. If I am giving you lambda, 2 lambda, 3 lambda, 4 lambda, what you will be saying? Sir, it is constructive interference. Now, can you judge just by looking at the path difference, it is constructive or destructive? If you are able to judge it, majority part of you have understood. Is it clear? Because I will tell you, all these things are connected. Every single thing you are going to derive, not me. You are going to derive, just be with me. Okay. So I can say till here it is clear. Now, just by looking at the path difference, and path difference is the most important thing in all the questions, all the derivations, we are going to calculate this path difference term. Once you understood that. So path difference, if it is in terms of lambda, 2 lambda, 3 lambda, 0, 5, 6, 7, 8, 9 and so on, it will be constructive. If it is a kind of 1 by 2, the multiplication of lambda, lambda by 2, 3 lambda by 2, 5 lambda by 2, 6, 7 lambda by 2. So all these terms, if it is coming, it is called as destructive interference. This kind of part difference will be having. Correct? What are the interpretation of this constructive and destructive? Actually, it is made as a bright fringe and dark fringe. That is also I will be explaining. Just wait for a moment. As of now, we are just creating the condition for our final derivation. Now all the derivations that I have did, all the things are present here. Don't worry for anything. Here it is the explanation for destructive interference. Destructive interference you have printed. The part difference is equal to 2n plus 1 lambda by 2. Correct? Destructive interference, finally it is represented this amplitude. If amplitude is equal to both the cases was a, here see y1 is equals to a and y2 is also equal to a sine of omega t minus of kx plus of pi. Okay, so amplitude was same, phase difference is pi, so the resultant amplitude put karo value a1 square and a1 and a2 both are same, and cos phi is equals to pi. So how much the value you will be getting? Calculate it. You will be having finally 0. Check kar sakte ho, cross check it from the formula. Okay, very good. Now it's the time for Young's double slit experiment. Now you will understand what is complete Young's double slit experiment. Okay, so we start. Okay, see, I've told you now in that debate that Huygens have given it his theory that light is a wave nature. Okay, he have given his theory of a wavefront also, but no one has accepted it. Okay, because Newton was sitting there and he have said that okay, light is a particle nature. It is a corpuscular theory was there. Okay, that's why no one was agreed. But then came a scientist after nearly 100 years, near about. A scientist came, Young's, and he have performed a very great experiment, Young's double slit experiment, that proved, that forced everyone to prove that light is actually particle nature. Okay, light was actually particle nature. What was that experiment on all this? There is a statement about that experiment that you will be studying, that is available. I am going to explain you the complete experiment. See here. See, all those important points notes are available here. I am going to practically explain you what was that experiment. Okay, see, there was a light source. Okay, here is a light source. Okay, if it is a light source, using Huygens principle, can I say it will have its own spherical wavefronts? Correct? Yaad hai na? Abhi just before some time back we have studied about it. What you have did, obviously there will be this kind of wavefronts will be there, and light will be propagating in this way. Light will be coming. Correct? See? Now what you have did, for interference, tell me, for interference, for performing interference, what are the requirements? You should be having two wave sources at least, because if there is not two waves, how you will be performing interference? Interference is, so how you will do superimposition? Y is a resultant equation, that is y1 plus y2. So for that he have created two. But what was one more important condition, that the waves should be coherent for interference. What should be the wave? Wave should be coherent. So he have applied a lot of brain, and what he have did, because making the phase constant, making the phase difference constant is a very tough thing. If we are watching these two lights, phase difference is changing in just seconds. Okay, it is so fast that you cannot watch it, you cannot absorb it also in the lights that is happening. So creating a coherent source was itself a very tough challenge. So what he have did, understand here, he have taken a source, and then what he have did, he have applied a cardboard kind of thing. Yeah, 3D I am drawing. Okay, he applied this kind of thing, and he have cutted two very thin slits. You have cut it very thin slits. I am making a little bit bigger here. Very thin, like blade. You have seen the edges of blade, that much of. And then he have performed all the things that are coming here on a screen. This was the screen. This was the setup of YDS, Young's double slit experiment. Now see what was happening actually. Light was coming, and you know that all when you are having a wavefront, all the points on these wavefront will start behaving like a new wavefront. That means it will start like making like a new point source. Again there will be a second wavefront. Now again wavelets will be coming. All the points on this wavefront will be behaving like a new point source. So I can say light will be reaching, some light will be reaching at this point also, and some light will be reaching at this point also. Correct? Some light will be reaching at this point, light traveling, and some light will be reaching at this point. Now, the wavefront that will be made here, can I say that point will also start behaving like a new point source and other lights are blocked. Only two light rays are coming here. So can you say now it is going to behave like a new point source and it will be making its own wavefronts. Now it will be making its own wavefronts. And I can say second point is also going to behave like a new point source and it is also going to make its own wavefronts, spherical wavefronts. Correct? Now what will happen? Light rays will be propagating like this way. If this is green color, light rays will be propagating in this way, in the forward direction. And from here also light rays will be propagating. Light rays will be coming and it will be forming some pattern on the screen. That is what observed by Huygens. Now, what is this pattern that is observing here was interference pattern. Okay, some bright spots were observed, some dark spots were observed, and you know how beautifully this was represented as S1, this was represented as S2. This was behaving like one source, this was behaving like one source, and I can say he have created a coherent source using these two thin slits. How I can say, because both these sources, it is coming actually from a single source. Originally, the light that is coming here is coming from the same source. That means he have not used two sources, he have just cut two thin slits and he have created, it was behaving like 2-point sources, and the light rays was coming and they were performing some interference and all the conditions that we have to observe. Part difference, every places will be writing part difference and the rest of the things. Then we will see what kind of pattern here. This pattern is called as fringes. Somewhere bright spots will be there, some dark, some bright, some dark. This kind of pattern is observed on the screen. So basically I have to tell you what was the setup of YD SE. Is it clear? This was the setup. Now let's come to see some theoretical things that is present here. See, he was the scientist Thomas Young. He have performed this experiment. Here you can see what is the condition. You can see here is a light source. He have created two thin slits, very thin slits, and he have started observing some pattern. You can see here a bright spot is coming here, again some dark space, again some bright space, again some dark space. On the wider vision you will see it is a pattern that will be formed on the screen. Here the same thing that I was shown you. It is a light source. Two very thin slits are made, source slit 1, slit 2, and again they are behaving like a new point sources, and again they are making their own wavefront. That means light will be coming from here also, from here also, and they will making some pattern on the screen. Correct? One more thing I forgot, there should be a monochromatic light. From polychromatic light, what will be happening, that is a different case. We will be understanding about that. I forgot to mention that light will be monochromatic. That means single color light should be there. Okay. All these theories are provided for you. You can see, you can read it out. What are the conditions? Important point is here. Condition for light waves to be coherent, constant phase difference, and same wavelength and frequency. That initially I have told you also. Okay. Now, if I have to tell you about the quantitative analysis, this was a quantitative analysis, qualitative analysis. Now let's do the quantitative analysis of YDSE. That means now let's come back to the formulas. Okay, fine, we have created everything, but what about the formulas? So let's again draw the same setup, and now let's come to the calculations and the approximations. See, approximations are very, very, very important in this chapter. You have to understand all the approximations from the basis. Okay, so what are the things? Let's again draw properly here. Now this time I'm not drawing the source, I'm drawing only the two thin slits. This is slit 1, this is slit 2. This is the screen. This distance from the slit to the screen is represented as capital D. These are the conventional sign, normal sign convention. This is the center point. The distance between these two thin slits is small d. Distance between these two thin slits is called as small d. Okay. Now see what will be happening. See what will happen. Light will be coming from source 1. Okay. Let's suppose some point P, and light will be coming from source 2 as well. At point B, it will be reaching. Correct? Now, I've told you the most important thing, and the question that will be coming, tell me better, what is the path difference at point P? If you are able to write the path difference, you can create literally everything. So what is the path difference? Now here comes the approximation one. And let's suppose this distance is y. This distance is y. We draw a third line from the center and we connect it, and let's suppose this angle is theta. Let's suppose this angle is theta. What we say, first approximation 1, very very important. Approximation 1 is that this d that is present here, this d is a lot bigger than the this smaller d. That means you have to understand it and you have to absorb it now, that if this distance is very larger, very larger, and this distance is comparably very small. This voice is clear now? Fine. So what you will be assuming, that here it is not looking parallel, these three lines are not at all looking parallel, but imagine a thing that is at very large distance. Let's suppose these are the 2 points, these are the 2 points S1 and S2, and I will say, let's suppose it is going at a very far distance here. Let's take example of moon. Two light sources going from here to the moon. So can you say both will be from that much of long distance? Can you say they will be appearing not two sources, they're actually looking like a one source? See, if you are watching in the skies, what is happening with the two stars? What is the distance between them you are observing? Very less, negligible, but they are very light years far away from each other, correct na? So when it is a longer perspective, I will say both these lines are parallel. Now you have to understand, if both these lines are parallel, how I can write the path difference. Path difference will be simply what? Path difference will be simply, if I have to name these points, let's how you can write, who is traveling more, source S1 or source S2? Who is traveling more? I will say source S2 is traveling more. S2P minus of S1P. S2P minus of S1P. Correct? So what I will say, and now you have to understand, if this angle is theta, I will say this angle is also theta. That means this angle is 90 minus theta and this angle will be theta. Correct? If this line is parallel, so how I can calculate? Now let's understand. If two lines are parallel, let's suppose I am telling you two lines are parallel. One is like this, one is like this. So if I have to calculate what is a path difference, can you say I will drop a perpendicular from line S1 on the line S2, and I will say, sir, this is the extra distance that is coming by traveling by light source 2. Correct? I will say drop a perpendicular from S1, and now you have to just judge this on the angle at some angle theta. So drop a perpendicular from here. Not this angle will be theta, complete angle. Drop a perpendicular here. Let's name this point as M. Let's name this point. So I've dropped a perpendicular, and I can say that this distance S2M is actually the path difference, extra path that is traveled by, because I've told you in the linear case, after that point S1 to SP is the same distance and M to P is the same distance. Both are parallel and both are traveling the same distance. mat dekho isko ki these are not parallel, these are the parallel lines. You have to absorb this. So what is the extra distance that is traveled here? I can say S2M. I can say what is the extra distance traveled here is S2M. If this angle is theta, this will be 90 minus theta, that means this angle will be theta. So tell me, what is this S2M? I can say define sine of theta in this triangle. If you are defining sine of theta, what you will be saying? Perpendicular upon base, perpendicular upon, sorry, hypotenuse. Perpendicular, what is a perpendicular? This S2M is a perpendicular, and correct, S2M divided by hypotenuse, that S2M is the extra part. That means I will say this is a part difference, and hypotenuse is D. So if I have to write S2M, I will write it as, I can write delta x is equals to D sine of theta. Define sine of theta, you will automatically have. So what is the part difference that you will be having, students? Delta x is equal to D sine theta, and literally it is a very important thing. Very important. Is it clear? First result that you have to remember. Most of the cases, now the approximation 2 will be coming into use. Nearly easier questions will always use approximation 2, but you should be knowing the approximation 1 also. After approximation 1, what is the result? Most of the time students just go and blindly remember the results. They don't know which approximation gives you what result. Now comes here the approximation 2. Now what is approximation 2 also? Approximation 2 says that this distance y is also very less than the comparable to distance d. With respect to this distance d, this y is very small. If this y is very small, due to that what will be happening? Theta is very small. And you know, my students, if theta is very small, what you can say? You can say tan theta is equals to theta, and it is equals to, can be written as directly as sine of theta. It can be directly written as sine of theta. So what I can say, after approximation 2, if in case approximation 2 is valid, that will be happening in the 90% of the cases, you can say this part difference can be also written as d tan of theta. Sin theta is equal to tan of theta, and tan theta, if you are defining here, what will be writing? Perpendicular upon base. That means part difference will be written as dy by capital D. Dy by capital D. This is what the quantitative analysis that you will be having. Formulas, part difference. Once you understand part difference, then the rest of the world is very easy. Is it clear? If still there is any doubt, because it takes some time to absorb the thing, first thing that will be facing problems, sir, how it will become parallel. Imagine karo, try to get into this socho is environment, the moon example that I went, not it will be looking like, I will say that sir, it is not actually parallel, but it is looking like parallel. It will be much similar to parallel lines, because we have to use the property for the derivation. We have to do this. Is it what it is? What it is? Okay. Next thing that was important is the second approximation. If this line is very small, let's suppose this is this much as compared, so can you say the line that will be coming from here is also incomparable, 4 degree, 5 degree, theta is very small. If theta is very small, what is the property? Sin theta is equal to tan theta is equal to theta, and exactly we have used that property, and then we have written delta x is equal to dy by capital D. Is it clear? If you'll need any doubt, please not hesitate to comment down in the comment section. I will be taking an extra doubt session for you also from this regarding this chapter, but you have to tell me in the comment section. Okay, so now let's see the derivations also. Here finally the part difference that will be completely properly, it is diagram is drawn, so there is no problem. You'll be getting from here. Okay. Now the light that has came here on the screen, again let's draw the diagram, and now this time we know the results. This was what? Now I'll tell you about the pattern. S1P, S2P. Okay. This is source 1 behaving like this is source 2. This distance is what? D. This distance is what? Capital D. Correct? Now what will be happening? Some light sources will be coming in. Some light sources will be, and I've told you at point P they will be superimposed, and what is the part difference that just now we have studied? It was equal to d sin theta by approximation 1, and let's assume that both the approximations are valid. So what I will say, it is equals to dy by d. It is equals to dy by d. Part difference. Now what we have to understand, now let's come again back to the constructive and destructive interference. That's why I have told you that it is very important here. Remember it. Now in light, what is the meaning of constructive interference? I will tell you. In a dark room, if you are properly doing this in a dark area, when only two light sources are coming, coherent sources should be mandatory. The interference, if there is a constructive interference, that point will be looking like a very bright spot. That point will be looking like a bright spot. And if it is a case of destructive interference, that point will be looking like a dark spot. That is what now you'll observe what kind of pattern that we are going to get. What kind of pattern that we are going to get here. So now let's understand here. Okay. See, tell me at this point, what will be having part difference at this center point. Light ray, kaun sa color use kiya yaar? Some light will be coming from here, and some light will be coming from here. Okay, exactly at the symmetric point. So can I say S2 and S1? This is S1, sorry. This is S1 and S2, both are traveling the same distance. Yes or no? Both are traveling the same distance. So what I can say about part difference, can I say is it equals to 0? If part difference is equals to 0, what kind of point I can say it is? What kind of point it is I can say? Yeah. What is the point? What I can say about this point? If part difference is equals to 0, lambda, 2 lambda, 3 lambda, 4 lambda, what I have told you, that it will be called as a point of maxima, and we name this central point because this is the central point. After that, it will be some pattern behind this also, some pattern. This point is called as central maxima. Yaad rakhna. What is this point is called as? Central maxima. And what kind of point it is? Obviously, it is constructive interference. And if it is a constructive interference, you will have it as you will be calling it as a bright spot. All these things are same. all these things are same. Okay, now let's move further. Let's see some examples. Let's suppose here part difference, here it is 0. Let's suppose here part difference is coming lambda by 2. Who is traveling more? Again S2 is traveling more. If part difference is coming lambda by 2, what I will be saying, this is the point of constructive interference or destructive interference. What will be saying? I will say, sir, it is, if it is lambda by 2, yaad karo, destructive interference, lambda by 2, 2 lambda, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. That means if it is part difference is equal to lambda by 2, you'll be saying, sir, it is destructive interference, and the name for this point that we give is first minima. What we call first minima. And if it is minima, what kind of spot it is? Actually, it is a dark spot. This will be feeling like a dark spot. Here it will be bright spot, dark spot. Then further move ahead. Some rays will be coming from here, and some rays will be coming from here as well. Okay. Let's suppose I am giving that part difference is equal to lambda. Part difference is equal to lambda. Now you tell me what kind of interference it is, constructive or destructive? Sir, it is constructive interference. Constructive interference, that means what is the name that I am going to give? This maxima was called as central maxima, and this maxima is called as first maxima. This is called as first maxima. What kind of spot it is, bright or dark? This will be a bright spot. So this will be looking like a pattern, bright, dark, bright, dark, bright, dark. Okay. About intensity and the rest of the things also we will be understanding. Don't worry for that. So it is not happening on the one side only. It will happening on the other side as well, and the exactly same kind of pattern. Let's suppose here I am giving you delta x is equals to lambda by 2. Again, lambda by 2 means what? Lambda by 2 means it is a point of destructive interference. Destructive interference, what is the name I am going to give? This is also a position for first minima and a dark spot. Let's see. Here also some light will be coming. From here also some light will be coming. So I will be, let's suppose it is given as part difference is coming lambda. All this part difference will be coming. I will be telling you. That means what I can say, what kind of interference? Constructive interference. Constructive interference, what is the name I am going to? It is completely symmetric. If it is called as first maxima, it is also called as first maxima. This is also called as first maxima, and it will be a bright spot. It will be a bright spot. So I hope that now it is clear. I will be showing you a diagram also how actually this looks in a practical scenario. This is how, just by understanding what is a part difference, you can say, sir, it is a bright spot or it is a, whether it is a dark spot. Is it clear? समझ आया? कुछ आया? थोड़ा स्वल्पा? हाँ? So now the question will be, sir, can I find the distances also? As of now, I am calculating everything in terms of part difference. So can I find it in terms of distances also, absolute distances? Correct, I can find. Okay, let's understand how I can find in the same diagram, but otherwise I have to draw a different diagram as well. Well, let's rub this for a moment. Please remember all these points. Again, I am going to, you have to remember this, all these points. Correct. Nice. Now let's calculate in terms of distances. What will be the result that will be coming in terms of distances? Y. Okay. Understand. What is the part difference better that you have calculated by validating approximation 2, that is equals to dy by capital D. Dy by capital D. If I am telling you for constructive interference, it's not right here. Here I will be drawing the pattern. For constructive interference. For constructive interference, what is the delta x in general that you got is dy by capital D. And for constructive interference, already you have seen what is the part difference that you got, that is equals to n lambda. That means 0 lambda, 1 lambda, 2 lambda. So if I have to calculate what is this y, the distance, I will say what it is equals to d n d lambda by d. Always remember in this way. Why? I will be telling you, because this complete term is called as fringe width. This complete term is called as fringe width, and I will tell you a shortcut also that we will be discussing in next class. You don't have to remember in this method. Now come to the destructive interference. Destructive interference, what is the part difference that is in general that you have calculated, that is equals to dy by d. And specifically for destructive interference, the part difference is equals to 2n plus 1 of lambda by 2. That is what you have created the condition. Now y can be written as how much? it will be equal to 2n plus 1 d lambda divided by 2d. That means what kind of positions here are coming? If I will ask you, tell me here what kind of positions are coming. So we'll say, sir, y is equals to 0, y is equals to d lambda by d, y is equals to 2d lambda by d. Just put n is equals to 0, 1, 2. And here if I will ask you, tell me what kind of positions that you will be giving me. Put 0. When you are putting 0, y is equals to d lambda divided by 2d, y is equals to 3d lambda divided by 2d. Okay. So let's see. What was the part difference here, beta? Part difference is equals to 0. I've told you now what is part difference? 0, and it is called as central maximum. So see, what is the distance coming for first maximum? Can you say from here we calculate always y? So I can say y is equal to 0, and exactly what kind of maxima distance that is given? It is given for central maximum. Are yes or no? Correct. Now let's come to this point. What was this position? This was the x is equals to lambda by 2. That means if I will ask you, tell me what is the distance of this minima position. Red pen, I am representing minima. So what will be saying? Sir, y1 is equals to, what is the first minima that is coming? Put here n is equals to 0. N is equals to 0 will give you the first minima position. Put it, how much you are getting? This distance y1 is equals to d lambda divided by 2d. Let's suppose you want to check what is the distance of the first maxima. This was what? Your first maxima. What is the part difference? Part difference you have written as lambda. So let's suppose you want to calculate this y. Let's represent y2. This is just a representation y2. How will be representing? First maxima is already done. Now what you will be putting here? And d lambda by d. Here you have already put in 0. Here now you will be putting 1. When you are putting 1, what is this distance is going to come as? D lambda by d. And this d lambda by t is actually taken as beta. Further I will be telling you about fringe width. That means this will be beta, this will be beta by 2. Okay. Now after that it will become 3 beta by 2. Then after 2 beta, this way it will be keep forming. Here in the other side also, let's suppose here you want to calculate, sir, tell me this is a position for y1 minimum. What was the part difference that you got here? Lambda by 2. So if you have to calculate the distance, how will be calculated? Distance will be same exactly. That will be equal to d lambda by 2d. Exactly symmetric. The pattern is exactly symmetric. D lambda by 2d. If you have to calculate what is the maxima, a lot of color I have used today. y2, here it will be part difference is equals to lambda. What kind of position it is? It is a position of first maximum. For a position of first maximum y2, how I will be writing? Put n is equals to 1. Here you will be having d lambda by d. Is it clear? So if I will tell you what kind of pattern that you will be having on screen, there will be, if it is available, I'll show you. I'll show you the diagram by drawing only. If you want to see what kind of pattern that on the screen, that screen that we have connected here, see, this kind of thing will be happening. Firstly, this will be a pattern that will be forming. This will be called as what? Central maxima. After that, it will be the position for first minima. I am not drawing anything. Then you will again watch a bright spot, that will be first maxima. Then you will be having a position for second maxima. On the other side also, from the reference level, it will be same. This will be first maxima. Again, this will be second maxima. These points are dark spot. This is the minima. This is also the minima. This is also the minima. This is first minima. This is second minima. Again, here from the reference line, this is first minima. This is second minima. This kind of bright dark, bright dark, bright dark, bright dark, this kind of formations will be there. Is it clear? You can see all the results are available here, that what we have studied. First dark fringe. Let's see from the constructive interference. Constructive interference, I have told you that it will be equals to, it is also for destructive here. Constructive interference. What is the in general condition? Y is equals to what you have calculated. It was equals to n d lambda by d. Y nth, what you will be calculating in general, n d lambda by d. Now just keep putting 0, 1, 2, 3, and this way you will be having all your distances. First one is called as central maxima, and then same way there will be for destructive interference. Destructive interference, what is the value that will be having? 2n plus 1 or lambda by 2, that is a part difference. Now why does minus is also coming, that I will tell you. You don't have to get confused into it. It is either you can use minus also, either you can use plus also. I will tell you in the next class when we watching about fringe width properly. Again we'll be seeing the pattern. So these are the points. In general you will be writing what, 2n plus 1 d lambda by 2 also you can put, no problem. All the answers that here you will be having same, lambda by 2 plus my, actually due to that what is happening, you are having only the positive sides. So to having the negative sides, you can put negative values also. Lambda by 2, 3 lambda by 2, 5 lambda by 2, this kind of part difference will be there. And the distances that we'll be getting is in terms of d lambda by 2d, 3d lambda by 2d, 5d lambda by 2d, this kind of distances you'll be getting, and this kind of part difference you'll be getting for destructive interference. So this complete notes will be available for you, but whatever I've explained, that was the most important one. Try to understand in that way. Okay, it will be much better for you. In the next class, again I'm going to continue from here. Again I will draw the fringe pattern. I will tell you what is fringe width. I will tell you about intensity. All these things we'll be discussing. Young's double slit experiment is one of the most one, so we can take some time into that. Okay, try to, if it is not clear, try to watch the video again and go in the sequence, because sequence is the most important thing. If you are blindly just remaining the formula, not knowing from where it is coming, you are always going to make mistake. I will tell you some questions where approximation 2 will not be valid, then all these things that you have derived now, it is invalid. If by chance approximation 2 is not valid, then all these formulas that you have written will become invalid, because now you have to go conventionally from d sin theta and rest of the thing. We'll be discussing about that. Fine. So until next time, keep learning, keep growing with Tapasya, Endigo, and then Digo, Nama Tapasya.